Solutions to questions involving equations and expressions. Let the sum of x, y, and z equals 7 be equation 1. And the product of x, y, and z equals 7 be equation 2. Finally, the sum of reciprocal of x, reciprocal of y, and reciprocal of z equals 13 divided by 7 be equation 3. Consider equation 3. The LCM is the product of x, y, z. It implies that the sum of the product of yz and the product of xz and the product of xy, all divided by the product of x, y, and z, equals 13 divided by 7. Substitute equation 2 for x, y, z. We have new equation as shown on the screen. Cross-multiply the new equation obtained. We have that the sum of yz and xz and x, y equals the product of 7 and 13 divided by 7, which equals 13. We call it equation 4. Simplify the given expression, which is the product of 1 plus the reciprocal of x and 1 plus the reciprocal of y and 1 plus the reciprocal of z. We have that the product x plus 1 and y plus 1 and z plus 1, all divided by the product of x, y, and z, as shown on the screen. Expand brackets and we have that the sum of x, y, and x and y and 1, multiply by the sum of z and 1, all divided by the product of x, y, and z, equals x, y, and z plus xz, plus yz, plus z plus xy, plus x, plus y, plus 1, all divided by the product x, y, and z. Rearrange terms of the numerator and we obtained a new equation, as shown on the screen. Substitute equation 4 and equation 1 into the above new expression. The sum of 7, 13, 7, and 1, all divided by 7, equals 28 divided by 7, which equals to 4. Therefore, the product of the sum of 1 and the reciprocal of x and the sum of 1 and the reciprocal of y and the sum of 1 and the reciprocal of z equals to 4. Solution to question 2. Let y equals the quartic root of 1 minus x. Take the quartic power of the equation. It implies that the quartic power of y equals 1 minus x, as shown on the screen. We call it equation 1. Rearrange terms of the equation. We have that x equals 1 minus y to the power of 4. Also, the sum of x and 15 equals 1 minus y to the power of 4 plus 15, which equals to 16 minus y to the power of 4. We call it equation 2. Substitute equation 1 and equation 2 into the given original equation. This implies that the sum of quartic root of 1 minus x and quartic root of x plus 15 equals the sum of y and the quartic root of 16 minus y, which equals to 2. Rearrange terms of the equation, as shown on the screen. Find the quartic power of the equation. It follows that 16 minus quartic power of y equals to the quartic power of 2 minus y. Expand bracket. 16 minus y to the power of 4 equals y to the power of 4 minus 8 times y to the power of 3 plus 24 times the square of y minus 32 times y plus 16. Rearrange and combine terms in one side of the equation. It signify that 2 times y to the power of 4 minus 8 times cube of y plus 24 times the square of y minus 32 times y equals 0. Divide the equation by 2. And we have that y to the power of 4 minus 4 times cube of y plus 12 times the square of y minus 16 times y equals to 0. Using the rational root theorem. The possible roots of the equation. The ratio p is to a equals the ratio of factors the last term to the factors of the first term, which equals to 0, plus or minus 1, plus or minus 2 and so on, as shown on the screen. For f of y equals 0, we have that 0 equals 0, after substituting into our derived equation. This is a true statement, which means that y equals 0 is a root to the quartic equation. Let us substitute y equals to 1 into the derived equation. Notice that the result is not equals to 0. Also, if we substitute negative 1, the result will not be equals to 0. For this reason, y equals plus or minus 1 are not roots to our obtained quartic equation. Let us check for y equals 2. It implies that 2 to power of 4 minus 4 times cube of 2 plus 12 times square of 2 minus 16 times 2 equals to 0. It implies that y equals 2 is a root to the quartic equation. We factorize the quartic equation, so that the product of y and cube of y minus 4 times square of y plus 12 times square of y minus 16 times y equals to 0, as shown on the screen. This implies that y equals to 0, or cube of y minus 4 times square of y plus 12 times y minus 16 equals 0. To find other roots using long division. Since y equals 2 is a root, then y minus 2 is a factor of the equation. Cube of y minus 4 times square y plus 12 plus y minus 16 equals 0. We obtained another root, which is the square of y minus 2 times y plus 8. The procedure used to obtain this root is by long division method, as shown on the screen. The other factor of this equation, cube of y minus 4 times square of y plus 12 times y minus 16 equals 0, is square of y minus 2 times y plus 8. We can find the two roots of obtained quotient, which are complex results or roots, using General quadratic equation formula. Substituting into the formula, which we already known, we have that y equals 2 plus or minus the square root of square 2 minus the product of 4, 1, and 8. All divided by 2 times 1. Which equals to 1 plus or minus I times the square root of 7. After simplification of substituted values. Since y equals quartic root of 1 minus x, and x element of real number, y equals 1 plus or minus the product of I and the square root of 7. This implies that y equals 0 or 2. When y equals 0, y equals quartic root of 1 minus x, which equals 0. Find the quartic power of the equation, as shown on the screen. We have that 1 minus x equals 0. It implies that x equals to 1. When y equals 2, y equals quartic root of 1 minus x, which equals to 2. Find the quartic power of the equation. Simplify and we have that 1 minus x equals 16. X equals 1 minus 16, which equals negative 15. Therefore, the value of x that satisfy the given equation is 1, or negative 15. Solution to question 3. Let the sum of square of x and square of y equals 1 be equation 1. Since it is only one equation that is given, it can be solved by method of inspection. Let x equals 1 and y equals 0. It implies that x and y equals 1 and 0 is one solution to equation 1. Again, let x equals 0 and y equals 1. It signify that x and y equals 0 and 1 is another solution to equation 1. These are possible solutions to equation 1. Let us test two more expected solutions. Let x equals 1 divided by the square root of 2, and y equals to 1 divided by the square root of 2. It follows that x and y equals reciprocal of square root of 2 and the reciprocal of square root of 2 is one possible solution to equation 1. Also, let x equals 1 divided by square root of 3 and y equals 1 divided by the square root of 2/3. This value of x and y is another possible solution to equation 1. Let us verify that these four possible solutions of x and y, that is 1 and 0, 0 and 1, inverse of square root of 2 and inverse of square root of 2, inverse of square root of 3 and square root of 2/3. For each, actually satisfied equation 1 by method of substitution. 4x and y equals 1 and 0, respectively. The sum of square of x and square of y equals the sum of square of 1 and square of 0, which equals 1. Since left-hand side of the equation equals the right hand of the same equation, 1 and 0 for x and y, respectively, is a required solution to equation 1. For 0 and 1. The sum of the square of x and the square of y equals the sum of square of 0 and the square of 1, which equals to 1. Since LHS equals RHS, 0 and 1 is a required solution to the equation 1. For inverse of square root of 2 and inverse of square root of 2. The sum of the square of inverse of square root of 2 and the square of inverse of square root of 2 equals the sum of half and half, which equals to 1. Since LHS equals RHS, inverse of square root of 2 and inverse of square root of 2 is a required solution to equation 1, as shown on the screen. For inverse of square root of 3 and square root of 2 divided by 3. We substitute into equation 1. To verify if left-hand side equals the right-hand side of the equation, which proved to be true. For 1 equals 1 is a true statement. It implies that 1 divided by the square root of 3 and the square root of 2 divided by 3 is a required solution to equation 1. Note that any of these proved solutions will satisfy the result of the given expression. That is, the sum of the square root of square of x to power of 4 plus 4 times square of 2, and the square root of the sum of y to power of 4 and 4 times square of x. When x and y equals 1 and 0, respectively, the sum of the square root of x to the power 4 plus 4 times square of y, and the square root of y to the power of 4 plus 4 times square of x equals. Substitute values and we have the sum of 1 and 2 equals 3, as shown on the screen. Test other values of x and y we obtain to verify if the answer is 3. Therefore, the correct option is B. Solution to question 4. Cross-multiply the given equation. The product of x and 4 to the exponent of x equals 1. We call it equation 1. The easiest method to solve this question is by trial and improvement method. Let x equals negative half. Substitute into equation 1. The product of negative half and 4 to the exponent of negative half equals negative 1/4. After simplification of substituted value, as shown on the screen. Since left-hand side is not equals to the right-hand side of the equation, x is not equals to negative half. Let x be equals to half. Substitute into equation 1. We have that The product of half and 4 to the exponent of half equals the product of half and 2, which equals to 1. Because the left-hand side equals the right-hand side of the equation. That is, 1 equals 1 is a true statement. X is equals to half. Therefore, the required value of x that satisfy the given equation is half.